everyone. Welcome back. Welcome back. I'm Jeremiah, and this is Andrew. We are here from the TensorFlow Hub team. We're based in Zurich, Switzerland, and we're excited to share TensorFlow Hub today. So this first slide is actually one that I stole. I took it from a colleague, Noah Fidel, who leads TensorFlow Serving. And Noah uses this slide to tell a personal story. And it kind of shows the growth of things, the type of tools that we use to do software engineering. And it shows how they mature over time. And he also connects this to a similar thing happening for the tools we use to do machine learning. Right? And he draws these connections. Right? We're rediscovering things as we grow our machine learning tools. Things like the machine learning equivalent of source control, the machine learning equivalent of continuous integration. And Noah also makes this really interesting observation that this growth on the machine learning side is lagging behind the software engineering side by 15, 20 years. So this creates a really interesting opportunity, right? We can look at software engineering. We can look at some of the things that have happened there and think about what kind of impact they may have on machine learning. Right? And so looking at software engineering, there's something that's so fundamental, it's almost easy to skip over. And that's this idea of sharing code, shared repositories. Right? On the surface, this makes us immediately more productive. Right? We can search for code, we can download it, we can use it. But it has these really powerful second-order effects. Right? This actually changes the way we write code. Right? We refactor our code, we put it in libraries, we share those libraries, and this really makes people even more productive. And it's the same dynamic that we want to create for machine learning with TensorFlow Hub. TensorFlow Hub lets you build, share, and use pieces of machine learning. So why is this important? Well, anyone who's done machine learning from scratch knows you need a lot to do it well. You need an algorithm. You need data. You need compute power and expertise. And if you're missing any of these, you're out of luck. So TensorFlow Hub lets you distill all these things down into a reusable package we call a module. Those modules go in TensorFlow Hub where people can discover them and then easily use them. So you'll notice that I'm saying module instead of model. It turns out that a model is a little bit too big to really encourage sharing. Right? If you have a model, you can use that model if you have the exact inputs it wants, and you expect the exact outputs it provides. If there's any little differences, you're kind of out of luck. So modules are a smaller piece. Right? If you think of a model like a binary, think of a module like a library. So on the inside, a module is actually a saved model. So this lets us package up the algorithm in the form of a graph. Lets us package up the weights. You can do things like initialize, use assets. And our libraries make it very easy to instantiate these in your TensorFlow code. So you can compose these in interesting ways. This makes things very reusable. You can produce one of these and share it. These are also retrainable. Once you patch it in to your bigger program, you can backpropagate through it, just like normal. And this is really powerful, because if you do happen to have enough data, you can customize the TF Hub module for your own application. And to tell us a little bit more about some of those applications, I'll hand it over to Andrew.
Thanks, Jeremiah. Let's look at a specific example of using a TF Hub module for image retraining. Let's say that we're going to make an app that can classify rabbit breeds from photos. The problem is we only have a couple hundred examples, probably not enough to train an entire image classification model from scratch. But what we could do is start from an existing general-purpose image classification model. Most of the high-performing ones these days are trained on millions of examples, and they can easily classify thousands of categories. So we want to reuse the architecture and the trained weights of that model without the classification layers. And in that way, we can add our own rabbit classifier on top, and we can train it on our own rabbit examples, and keep the reused weights fixed. So since we're using TensorFlow Hub, our first stop is tensorflow.org/hub, where we can find a list of all of the newly released, state-of-the-art, and also the well-known image modules. Some of them include the classification layers, and some of them remove them, just providing a feature vector as output. And so we'll choose one of the feature vector ones for this case. Let's use NASNet, which is a state-of-the-art image module that was created by a neural architecture search. So you just paste the URL of a module, and TensorFlow Hub takes care of downloading the graph and all of its weights and importing it into your model. And in that one line, you're ready to use the module like any function. So here we just provide a batch of inputs, and we get back our feature vectors, we add a classification layer on top, and we output our predictions. But in that one line, you get a huge amount of value. In this particular case, more than 62,000 hours of GPU time went into finding the best architecture for NASNet and training the result. And then all of the expertise, the research, the testing that the authors put into that, that's all built into the module. Plus, that module can be fine-tuned with your model. So if you have enough examples, you can potentially get better performance if you use a low learning rate, if you set the trainable parameter to true, and if you use the training version of the graph. So NASNet is available in a large size as well as a mobile size module. And then there's also the new progressive NASNet. And then a number of new MobileNet modules for doing on-device image classification, as well as some industry standard ones like Inception and ResNet. That complete list is at tensorflow.org/hub. And of course, all those modules are pre-trained using the TF-Slim checkpoints, and they're ready to be used for classification or as feature vector inputs to your own model. OK, let's look at another example, in this case, doing a little bit of text classification. So we'd like to know whether a restaurant review is a positive or negative sentiment. So as Jeremiah mentioned, one of the great things about TensorFlow Hub is that it packages the graph with the data. For our text embedding modules, that means that all of the pre-processing is included, doing things like normalizing and tokenizing operations. So we can use a pre-trained sentence embedding module to map a full sentence to an embedding vector. So if we want to classify some restaurant reviews, then we just take one of those sentence embedding modules, we add our own classification layer on top, and then we train with our reviews while we keep the sentence module's weights fixed. And just like for the image modules, tensorflow.org/hub lists a number of different text modules. We have neural network language models that are trained on GNUs for English, Japanese, German, and Spanish. We also have Word2Vec models trained on Wikipedia, as well as a new module called Elmo that models the characteristics of word use and how those uses vary across context. And then there's also something really new, as in today. You may have seen a new paper this morning from Ray Kurzweil's team. This is the Universal Sentence Encoder. It's a sentence-level embedding module. It's trained on a variety of tasks, and it enables a variety of tasks, in other words, universal. So some of the things that it's good for are semantic similarity, doing custom text classification, clustering, and semantic search. But the best part about it is how little training data is actually required to adapt a module to your own problem. So that sounds great in our particular case. Let's try it on the restaurant review task. So we just paste that URL from the paper. And like before, TensorFlow Hub downloads the module and inserts it into your graph. But this time, we're using the text embedding column. That way, we can feed it into an estimator to do the classification part. And just like with the image retraining example, this module can be fine-tuned with your model by setting trainable to true. Of course, you have to lower the learning rate so that you don't ruin the existing weights that are in there, but it's something that's worth exploring if you have enough data. Now let's take a closer look at that URL. As Jeremiah mentioned, a module is a program. So make sure what you're executing is from a location that you trust. In this case, the module is from tfhub.dev. So that's our new source for Google-provided modules like NASNet and a universal sentence encoder. Over time, we would like to create a place where you can also publish the modules that you create. So in this case, Google is the publisher, and universal sentence encoder is the name of the module. And finally, the version number is 1. So TensorFlow Hub considers modules to be immutable. That way, you don't have to worry about the weights changing between training sessions. So that module URL and all of the module URLs on tfhub.dev include a version number. And you can take that URL and paste it into your browser and see the complete documentation for any module that's hosted on tfhub.dev. Here's the particular one for the universal sentence encoder. And then we also have modules for other domains besides text classification and image retraining, like a generative image module that contains a progressive GAN that was trained on Celeb A. And we added another module that was based on Deep Local Features Network, which can identify the key points of landmark images. Both of those have great Colab notebooks that are available on tensorflow.org/hub. In fact, the images here were created from them. And we're going to be adding more modules over time for tasks like audio and video over the next few months. But most importantly, we're really excited to see what you build with TensorFlow Hub. Use the hashtag TFHub when you build notebooks and share modules. And visit tensorflow.org/hub for links to our documentation, including examples with tutorials, interactive notebooks, and code labs, and our new discussion mailing list. So from Jeremiah, me, and everyone on our team in Zurich, I want to thank you so much.